Hey guys, sorry I'm not there today, so I am going to do the multiplying radicals examples with you via this video, and so you are going to fill out your handouts while we go through this, and then you will glue them into your interactive notebook, and you'll have that as a reference as you go through the worksheet for today. So we are doing 9.2 multiplying radicals. If I'm not mistaken, I think this is going on page 143, but don't quote me on that, just put it on the next available page after the examples that we have done in class on Monday. So determine if the radicals can be multiplied together. In order to multiply radicals, they have to have the same index. So in this case, this is square root of 15, and this is square root of 3. Since they're both square roots, then yes, we can multiply them. And the great thing about multiplying radicals is that you multiply the outside stuff together, and then you multiply the inside stuff together, simplify if you can, and yada, yada, yada. All right, so the first thing we look at is, like I said, the index. So this is an index of 2. And this is index of 2, and sorry that handwriting is so small. So, comma, yes, we can multiply. Alright, now looking at the next step, and you don't have to do this with each one, but I want you to have this written out so that you know why we can multiply those together. It has nothing to do with the radicand, the number underneath it. It's just the index of the radical symbol. All right, and so now we want to multiply the coefficients together. So then we have, I'm going to rewrite this, negative 4 root 15 times negative square root of 3. Right. So now what we're going to do is multiply the coefficients together. Right? So we're going to have the outside stuff together, negative 4 times negative 1. So that would, putting this over here, negative 4 times negative 1 is going to give you 4. Multiplying the radicands, those are going to be the numbers underneath. That is going to be square root of 15 times the square root of 3. Well, square root of 15 times the square root of 3 is going to give you square root of 45. And hopefully that is going to send a little bit of a red flag to you, because that has a perfect square factor. We need to simplify that. Right? And so looking down here, the square root, or negative 4 square root of 15 times negative square root of 3 is going to give us 4 root 45. So we're going to end up with 4 root 45. Now this is just like what we had done in 9.1 with simplifying the radicals. So now you need to look at the term underneath the radical and determine if you can factor that down and have a perfect square factor. And as I mentioned earlier, we do, we're lucky. So we're going to bring this 4 down because we're not doing anything with it yet. 45, and remember we're wanting to use a perfect square value. So we have 4, we have 9, we have 16, we have 25, 36, 49. I'm not going to go any further because 45 is less than 49. And so now I look at my perfect squares and starting from the largest and working my way down. So we have 36, nope. 25, nope. 16, nope. 9, woohoo. 45 is 9 times 5. So then we will rewrite this as square root of 9 times the square root of 5. Well, 4 still stays 4. Square root of 9 is 3. And then we have the square root of 5. So then we have 4 times 3, because those are the outside terms, get multiplied together, and that's 12. And then you have square root of 5. And that would be your answer. So the negative 4 times square root of 15 times negative square root of 3 results in 12 square root of 5. All right, now the next one, you are going to have to create a proof book. So yes, I know you guys can do this. Even though I'm not there, I shall make sure that there is a proof video available for you in Schoology to remind you of how to do this, okay? But I have all the confidence and faith that you guys can do this. And remember, you only get one because I only have enough copies for every single person. So if you cut it the wrong way, then you are going to have to somehow make that work. Right? And we're not going to glue this one in just yet. Okay, so do not glue this in. Put this in your back pocket when we get done going over the examples. Alright, so once you've got your proof book made, we have 3 root 12 times root 6. Okay, so we are going to do the same principle. We're going to multiply the coefficients together, and so this is going to be a coefficient of 1. So we have 3 times 1 is going to give us 3. Square root of 12 times the square root of 6 is going to give us square root, and then 12 times 6 gives you 72. All right, so now I need to determine if I can simplify 72. You may be tempted to just do 9. However, there is actually a larger perfect square term. So we have 4, 9, 16, 25, 36, 49, 64, and 81 is bigger. So now if we look at these factors, 64 is not going to go into 72 evenly. 49 will not go into 72 evenly. 36, woohoo, 36 goes to 72 2 times. So that's actually going to make our life a whole lot easier going with the 36 than doing 9 times 8 and then having to also break the 8 down. So then we have 3, breaking this down to square root of 36 times the square root of 2. Square root of 36 is just going to give us 6. So 3 times 6 is 18, and then you have root 2. And that is your final answer. All right, now looking at the second example, this one has variables, so we need to work on that. So we have 1 square root of 20x squared times 1 square root of 20x. So we multiply the 1's together. That just gives us 1, so I'm not going to write it. And then we have square root of 20x squared times square root of 20x. So then we know we're going to have the square root, and then 20 times 20, and hopefully you guys are catching on and knowing, well, that's going to give me a perfect square. X squared times x is going to result in a total of 3 x's, right? All right, so then this is the same as square root of 400 times the square root of those 3 x's. Okay, square root of 400 gives you 20. And then for the square root of x cubed, we have 1 pair of x's, so that 1 comes out. And then we leave this one, the one that's unmatched, underneath the radical. So then our answer is 20x square root of x. Oh, where'd it go? Sorry, I forgot that I put it down here below. Alright, and now we are going to do one more example from the proof book. We are going to save this one for 9-3, so you can just sit tight on that for right now. We've got square root of 15n squared times square root of 10n cubed. So again, we have a 1 and a 1 outside, so 1 times 1 is just 1. And then we're left with square root. 15 times 10 is going to give us 150. N squared times n cubed, so that's the same as having 2 n's here and having the 3 n's there, so that's a total of 5 n's, n to the 5th, right? Alright, and now separating this out, so we have square root of 150 times the square root of n to the 5th. So 150, perfect square factors. 4, 9, 16, 25, 36, 49, 64, 81, 100, and we can stop there because nothing is going into that, and we would have 121 and 144. Alright, so 100 is not going to work, 81 won't work, 64 won't work, 49, 36, 25. So I can get a 25 to go into this guy. So that's going to be the square root of 25 times, use your calculator if you don't know this off the top of your head. So 150 divided by 25 gives you 6. So that's how we get these. And then bring down the n to the 5th. And if you want, you can go ahead and expand that if it makes life easier for you. All right, square root of 25 is going to give us 5. Bring down the square root of 6. And then we have 1, 2 pairs of n. So that means I have 2 n's that come out front. And then I have 1 n that stays underneath. Multiply the coefficients together, giving you 5n squared, and then multiply your radicals together, giving you square root of 6n. And this would be your answer. All right. I hope that made sense, and hopefully the video is okay in my absence. I do have another video in the folder for you if you want to watch that one instead. Please let me know if you have questions. I'll be trying to monitor my email, but I should hopefully be back tomorrow. All right. Have a great day, guys. Thank you.